compute the given integral. We have the integral of 3 tangent x dx, which if we want we can factor out the 3 and write this as 3 times the integral of tangent x dx. Looking at the integration formulas below, there are two equivalent antiderivatives for the tangent function. The integral of tangent u du equals negative natural log absolute value of cosine u plus c, which is equivalent to natural log absolute value of secant u plus c. Which means in our case, the antiderivative of 3 tangent x dx is equal to 3 times negative natural log absolute value of cosine x plus c, which results in an antiderivative of negative 3 natural log absolute value of cosine x plus c, which is equivalent to positive 3 times natural log absolute value of secant x plus c. And now let's take a look at why natural log appears in the antiderivative, and also why there are two equivalent antiderivatives. Of course, if we wanted to, we could differentiate both of these functions, and we would get the original integrand function of 3 tangent x. But going back to the original integral, let's write the integral as 3 times the integral of tangent x is equal to sine x divided by cosine x dx. To integrate in this form, we'll have to perform substitution. Let's let u equal the denominator of cosine x, which indicates differential u or du is equal to negative sine x dx, which if we divide both sides by negative 1 indicates negative du equals sine x dx. And now let's write the integral with respect to u. Sine x dx equals negative du. Let's factor out the negative, and then we have du. And because the denominator is cosine x and cosine x equals u, the integrand function is 1 divided by u. And we know the integral of 1 divided by u equals natural log absolute value of u plus c, which indicates the antiderivative with respect to u is negative 3 natural log absolute value of u plus c. And since u equals cosine x, we can write the antiderivative as negative 3 natural log absolute value of cosine x plus c, which matches the antiderivative from the first integration formula. And now to show this is equal to 3 natural log of the absolute value of secant x plus c, we'll need to use the power property of logs, which remember states that y times natural log x equals natural log x raised to the power of y. Right now, notice the coefficient is negative 3, which is equivalent to 3 times negative 1. Let's move the negative 1 to the exponent position on cosine x, which indicates negative 3 natural log absolute value of cosine x plus c is equal to positive 3 times natural log of the absolute value of cosine x raised to the power of negative 1 plus c. And cosine x raised to the power of negative 1 is equal to 1 divided by cosine x. And therefore we can write the antiderivative as 3 natural log absolute value of 1 divided by cosine x plus c. And finally, we should recognize 1 divided by cosine x is equal to secant x, giving us an equivalent antiderivative of 3 natural log absolute value of secant x plus c, which is the second antiderivative we found above using the second integration formula. I hope you found this helpful.